Hey guys, welcome back to my channel where we explore interesting math problems. Today, we'll be looking at a fun logarithm problem. So the question reads, find the sum of the roots of the equation below. Log x base 3 times log x base 4 times log x base 5 equals log x base 3 times log x base 4 plus log x base 4 times log x base 5 plus log x base 3 times log x base 5. So if we keep it in this current form, it's very hard to manipulate it algebraically and solve for x. So we're going to use something called the change of base rule. As a reminder, it says that log of a base b is equivalent to log of a base c over log of b base c. So it'll work as long as both of them have the same new base c, which also means that the new base could be 10. So you could just rewrite this as log a over log b, and that's what we're going to use for today's problem. We rewrite all of these as log x over log of whatever the original base was. Since there's a lot of stuff going on here, let's condense it a bit. And we have this. Since log x squared is a factor of every expression, we can divide everything by log x squared. But before you do that, you need to realize that if log x is equal to 0, then that would be a solution to this equation. This is because 0 to whatever the power is still 0, and 0 divided by these things will still be 0, so it would just become 0 equals 0 plus 0 plus 0. So, while we do simplify this and divide everything by log x squared, we can also make a note that we have our first solution, which is when log x is equal to 0. Simplifying, we get that x is 1. So we can make a note of it up here so we don't forget. Now back to our simplified expression. Since there's a lot of common factors in the denominator, we can multiply this whole equation by log 3 times log 4 times log 5, which will give you this nice simplified expression. If that was a bit sudden for you, I'll give a quick explanation. Since we're multiplying by this log 3, log 4, log 5, the bottom part cancels out here. For this part, it cancels out log 3 and log 4. But since it doesn't have log 5 in the denominator, it doesn't get cancelled out and you get left with it. It's the same logic for the other two, except what remains is log 3 and log 4. Now to solve it further, we use something called the product rule. It basically says that log a plus log b is equal to log a times b. Since this part is the addition of logs, we can multiply everything inside, which is 5, 3, and 4, and get this. So now we know that x is equal to 60. And quick note, usually with logarithm questions you have to check the solutions to see if there are any domain issues. But here both of the solutions are positive, and it wouldn't cause any domain issues because you can log a positive number with no problem. So both solutions are fine in this case, and checking solutions aren't really an issue here. Now we can easily find the sum of roots, which is 61. Okay, that's it everyone. I hope you enjoyed this short one, and we'll see you next time.